Today we have in this 2012 Volkswagen Tiguan. It has a 2-liter TSI CCT letter code engine, and this car was in here 2 weeks ago and it had a series of trouble codes, some of which were lean related, and we fixed those, but it had a P0299, and I told the customer to drive it and see if that code reoccurred. We did some basic checks then, but we wanted to see if it would reoccur, how bad of a problem it was, and today it's back with the check engine light on. So since it's back with the check engine light on, I would assume that the P0299 has reoccurred. And there, yes, it has. Before I clear it, I want to at least go check fuel trim, because we did a crankcase vent valve for a fuel trim problem 2 weeks ago, and I want to make sure that's all okay. And obviously clearing codes will erase fuel trim. 32 and 33. So I just seen short-term fuel trim here go positive, yep, and then go negative. So I assume that's working a reasonable amount. Under load, it's adding a little bit of fuel there at 3.9. Maybe that's due to the P0299 trouble code. Let's go drive it without clearing it and see what. I'll take a boost graph and then show you the graph after I get done with the test drive. The measuring block for boost on this car is 115. You can see there, specified and actual. So I'll click graph. Okay, I've driven this Tiguan some, and generally boost control is good. If you've watched any of my boost related videos before, you know that there's an actual and a desired. And on this car, the yellow is desired, and you can see that it's expecting about that much boost, but boost only comes up to the white, and that is probably our problem. Now, this seemed to happen about 60 miles an hour on the highway, and it was a situation where I backed out of the throttle and coasted for a second and then stepped back in slightly. I had been driving it at wide open throttle, trying to, give it the most boost it could, but that didn't seem to be where the problem happened. I'm going to drive this a few more times and see if I can duplicate this every time. I am going to go ahead and clear the code now and see if the code will reoccur. Okay, I'm back at the shop, and here's the graphs that I took. This is what I'm trying to demonstrate here is I was stepping into the throttle more. Here's desired boost and here's actual boost, and as I step into the throttle, actual boost never makes it up to desired in that whole time span there. And here's another one, and once again, actual boost doesn't ever make it up to desired boost. Now these are not at wide open throttle, these are all at partial load. Wide open throttle seem to be better. This is a much harder throttle. It seems to take quite a while for it to reach maximum boost, and then after it reaches maximum boost it seems a little bit, and then it isn't able to control it for just a brief period of time there. And I think I know why it's doing this. As I said, this car was here 2 weeks ago and we made some basic checks on this trouble code. This is a common problem. And here's a full wide open throttle, and you see boost comes up in a reasonable amount of time. It's out of control for just a little while, but then it's able to maintain boost at wide open throttle. Now, I'm pretty confident that this problem is happening at partial throttle, not at wide open throttle. And let me show you what we found. Okay, I'm videoing the lever there. There we go. I can show you there. This also has a lot of movement there where the rod meets the lever, and the anti-rattle clip will probably help that. Okay, Cortland has this turbo for this Tiguan out, and I want to point something out. Just as this thing sits here naturally, this moves easily, and it will come away from where that seats. So there's just obviously a big leak of turbine pressure coming through there.
Start my car because it's gonna be loud. There's some crazy lady out there across the street.
Well, hopefully this cop's going to arrest her or arrest whoever she's freaking out about.
She's literally like laying on the sidewalk sprawling. It's funny, I saw her Saturday with my friend and she's like screaming about meth. Some bigger lady. Same lady.
Trying to point out that just as this sits, it just sits there open. Any exhaust pressure comes behind it, it's just going to push it open because of the movement in the shaft here. Since we've done the initial checkout, I did some research and I did find a repair kit for this, which involves a new wastegate, a new lever, a new bushing, and it looks right. So let's see what we can do here. Okay, to start with, we need to get this clip off here. And I usually take a magnet because I don't want to lose the clip and stick it near it. And then dig around down it till it comes out. Okay, with the shaft out of there, you can see how badly the lever's worn. There's also some significant wear on the post that goes through that hole, and we may try and get a repair on that, or we might just put an anti-rattle clip on there, and that might hold it well enough. And with that lever off, you can really see the worst of the wear here. Okay, to install these repair kit parts, to start with, we're going to have to grind this weld off in order to get this lever off. And you want to install it in the same orientation, and I would get a protractor out and measure it, but it really looks like this just needs to be parallel with this surface here. Hoping I can drive the shaft out with a punch after I ground the welds off. I don't know if you can see that, but it definitely moved downwards. Lever out. Now the wastegate fell down when I punched on it. It's showing some significant wear right there. So it's not like you could reuse that without some type of repair there. Let's stick the new one in here and see if, well, let's compare the two. Okay, this wastegate will not go into this bushing. Okay, based on what I'm seeing here, this bushing looks the same size, and so probably we could drive that either through or out and then drive this one in. I'm hoping anyway. Might be best to apply some heat around here to get this up and out of there. think we're going to start with heat. We're not even going to try it without heat. Okay, we have here our original one. You see this notch in it? And the new one doesn't have that notch, but that notch needs to be there because there's a hole there for a roll pin, and that roll pin passes through that groove in order to set the height. And I didn't realize that when I drove this out, but I'm sure I can drill this out. Some nice chips coming out of there. Awesome. Just trying to dress the burrs from the drilling operation there. Okay, to the best of my ability, I've measured that out to about 6.5 millimeters. I'm going to paint this in order to make it easier to mark. I've locked my caliper on that 6.5 setting. Might show 6.49, but it's close enough. And then I'll just mark it like that. Let me get this in the vise first. Also want to pay attention to the depth of this. That's about 0.8 of a millimeter. .8 of a millimeter. Okay, I had some trouble properly orientating in order to, because this is stainless and the saw just slides across it. But if I put a pair of vice grips on there as a guide, I can kind of, and I'm using the end of the hacksaw because the teeth are sharper there. And I seem to be getting it pretty well on center on the line. And after I get it started, I won't need the guide. Yeah, I'm liking that. Mostly what I'm trying to do here is widen the groove. I've taken measurements on what the actual width is. And action. Here's our original, measuring the depth. And we have 8.4. Might have measured a little bit off that before. And measuring the depth on our new one. .3. I ain't gonna cry about 0.01 of a millimeter. Although I guess I could take a couple more strokes to clean it up a little. There's my final product on the groove. It ain't perfect, maybe a little bit big, but I am going to put some heat-resistant Loctite on it. This is Permatex 27200, and I'm not sure if that'll hold up in an exhaust manifold, but I've used it on spark plug thread inserts, and it works great there. I did think that maybe it would have been better to put this in the lathe and turn that groove all the way around. What could happen is the roll pin has to sit right in here, and if this is slightly out of orientation by being rotated, as I try and drive the snap ring in, it won't go in. Hopefully it'd be like that, and I'll drive it in and it'll be perfect. But I think a groove all the way around would probably be the way to go. Okay, I've made a decision. I'm going to go with this without a groove all the way around. And what I'm going to do is I'm going to sit it there, and I'm going to look into the hole and get a line of sight, and then look through the groove and get a line of sight and line it up that way. And I can even put a roll pin punch in there to try and help me line it up. Probably help if the roll pin punch was flat. Okay, and what I'm trying to show in this picture is if you really look closely, you can see that it's in line, and with it driven in that far, I can still grab it with pliers and rotate it, which is why I think the Loctite is definitely necessary. Whether or not it lives in this environment, I don't know. It really would be nice if that bushing was just a little tighter in the bore. Alright, that's all we can do. Hope we got it lined up good. If not, we'll have to drive it through and redo it. I think that worked. This stuff looks like blood. Just want to make sure this seat's in the right area, that the cup is entirely closing the hole. That is just perfect.